Hey everyone, welcome back to Context Window. So today we're tackling something huge, one of the biggest leaps in AI maybe ever. You see, for years, AI has been this ghost in the machine, right? Living purely inside our screens. Well, that's all changing. AI is finally getting a body. We've cut through all the noise to show you exactly how this tech is jumping from the world of pixels into our world, the one with atoms, gravity, and real consequences. All right, let's dive in.
For the longest time, our whole experience with AI has been through a screen. You know the drill. We've chatted with it, we've asked it to answer our questions, we've even had it write code for us. But what we're really digging into today is how that intelligence is finally getting eyes and hands and, well, the ability to actually interact with our physical reality. This isn't just a little step forward. This is the story of how AI is literally moving from the screen to the street. So here's the core idea, the big distinction. On one side, you've got the AI we all know, the chatbots and the image generators. And look, they're amazing at predicting the next word or the next pixel. But fundamentally, they are completely disconnected from the real physical world. On the other side, well, that's the new frontier, physical AI. These aren't just systems that talk anymore. These are systems that can perceive, reason, and, most importantly, act right here in our world. And the speed of this evolution has just been breathtaking. I mean, think about it. Just a couple of years ago, we were squarely in the experimental phase with large language models. That quickly led to deploying digital agents that could automate workflows. And now, right now, we're jumping into what people are calling the physical pivot. And the core tech that's making this all possible is something called a world model. This right here is the problem that this whole new phase of AI is built to solve. A chatbot can describe gravity to you perfectly, but it doesn't feel it, it doesn't understand it. It has no idea what's really going to happen when a glass of water gets knocked off a table. For AI to become truly useful in our homes, in our factories, in our hospitals, it has to graduate from just knowing facts to actually understanding physics. The old way just isn't going to cut it anymore. So that brings us to the million-dollar question, right? How in the world do you get a machine, it's just code and silicon, to actually grasp the chaotic, dynamic, and let's be honest, super messy nature of our physical reality? Well, the answer is a concept that is a total game changer. And that concept is the world model. Okay, imagine for a second you could give a machine an imagination. That is basically what this is. It's an internal simulator, a predictive engine that lets an AI run countless what-if scenarios in its own head, so it can understand cause and effect in its environment before it ever moves a single muscle. This quote just nails it. It perfectly captures the superpower. When you or I go to catch a ball, our brains aren't just reacting, right? They're constantly running a little simulation, predicting the ball's trajectory. A world model gives a robot that exact same predictive intuition, but on a superhuman scale. It can basically see thousands of possible futures in the blink of an eye. So how does this magic actually work? Let's pop the hood and take a look. The foundation for all this was laid way back in a groundbreaking 2018 paper by David Ha and Jürgen Schmidhuber. And they asked this revolutionary question: could an AI learn everything it needs to know about the world entirely inside its own dream? So they built a system with three main parts. You can think of it like this. First, you have the V model, which acts as the eyes. It takes in this overwhelming flood of visual data and just compresses it down to the most essential features. Then you have the M model, the predictive brain. It takes that compressed snapshot of the world and predicts what's going to happen next. And finally, you have the C model, the hands, which looks at those predictions and chooses the best action to achieve its goal. And here's the real kicker, the genius part of all this. The agent doesn't have to go out and fail thousands of times in the real world. Can you imagine? That would be so slow, dangerous, and crazy expensive. Instead, it can train entirely inside this simulated dream world that its predictive brain cooks up. It can literally crash 1 million virtual cars to figure out how to drive, all without a scratch. This makes failure practically free and learning incredibly, incredibly fast. That is the secret sauce. This really shows what a massive paradigm shift we're talking about. The old way of doing robotics relied on these fragile, hand-coded instructions. If sensor X sees object Y, then move your arm to position Z. It was so rigid, so brittle. The AI way just throws all of those rules out the window and replaces them with learned predictive simulations. The robot isn't told how to do something, it's just given a goal, and it uses its world model to figure out the best way to get there, adapting on the fly. And underneath all of this complex simulation is actually a pretty simple and powerful piece of logic. The future state of the world is just a function of the current state plus the action you're about to take plus everything you've already learned about how the world works. Physical AIs are constantly, and I mean constantly, running this calculation, predicting what the world will look like a few moments from now based on their very next move.
Okay, so that 2018 paper, that was the spark. Now let's talk about the fire that it started. We've covered the theory, so let's get into the real-world toolkits that are actually building this new generation of physical AI today. A huge player here is NVIDIA with its Cosmos framework. It's basically a full-stack platform for developers. With Cosmos Predict, you can generate training data for scenarios that are way too dangerous or expensive to test in reality, like a fire in a warehouse. Cosmos Transfer helps bridge that critical sim-to-real gap, making sure that what the AI learns in the simulation actually works in the messy real world. And Cosmos Reason gives these robots the ability to understand complex, nuanced commands from us. And what's got me really excited is the absolute explosion in open-source tools for this stuff. You've got frameworks like Crew AI that let you orchestrate whole teams of specialized AI agents. LangGraph is perfect for those really complex workflows where agents might need to loop and retry things. And for anyone just starting out, LiRobot from Hugging Face is making it super easy to jump in with pre-trained models. Now, this is a huge deal. Why? Because it means you no longer need a gigantic R&D budget to get your hands dirty. That barrier to entry, it's just plummeting, and that's pouring gasoline on the fire here. 6 million. Just let that number sink in for a second. By 2030, some projections are suggesting that up to 6 million humanoid robots could be manufactured every single year. This isn't science fiction anymore. This is the coming reality of a physical silicon workforce. And honestly, that's just the tip of the iceberg. The next 5 years could bring developments that right now feel basically impossible. We're looking at the potential for a recursive self-improvement loop. That's where AI starts designing even better AI, kicking off an exponential intelligence explosion. We're talking about smart homes that could proactively predict health issues, or cities that manage traffic perfectly in real time. And yeah, ultimately, this path could even lead towards what we call artificial superintelligence. But, and this is a big but, with this incredible power comes profound risk. The misalignment problem is no longer some theoretical topic for a debate club. Look, if a chatbot makes a mistake, you just get a wrong answer. But if a physical AI with a flawed goal is told to, say, get you a drink as fast as possible, it might just decide that walking through a glass wall is the most efficient way to do it. The consequences of an error are now physical. And that wraps up our deep dive into the rise of world models. For the first time, our most powerful tools are not just things we use, they're becoming autonomous agents that are going to share our physical space. They are stepping out of the screen and into our reality, which leaves us with a critical question. Are we ready? If this gave you a bit more clarity, or if it expanded your own context window, please share this. I've added the links to the frameworks and resources mentioned to the description below so you can check them out yourself. We're building this channel on your curiosity. If you have ideas for the next topic we should feed into the engine, drop a comment below. See you in the next one.